Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to another series of online lessons. If you haven't already, please subscribe to the channel and leave a like. Now, we continue from what we were looking at, and just basically we'll be looking at finding the expansion of some expression. So we'll be using the binomial theorem. Maybe you're given to expand x plus y to the power 3. How do you expand this? Well, in general, we know that this can be expanded by multiplying x plus y 3 times and x plus y like that, which will give us an answer. Or maybe you're given to expand a plus b to the power 2. We know this can be found by expand or multiplying a plus b 2 times. Or maybe if you're given a plus b raised to the power 20, well, expanding this 20 times is very tedious. So now this is where the binomial expansion comes in, or the binomial theorem. Okay, so basically, what does the binomial theorem says? Basically, the binomial theorem says if you have two variables, let's say x and y, two variables that you're expanding, and these two variables are raised to the power n, the binomial theorem formula is just equal to the sum from I, will use I equal to 0 to the n. So the n is this n that we have. Then we write n, choose I. So this can be any letter depending on what we're doing. Then we are going to have the first variable raised to the power I. So this is x raised to the power I. So we can put in brackets x raised to the power I. Then the second letter, which is y in brackets, raised to the power n minus I. Okay, so that is the binomial theorem in general. Now, what is I? So I, these are numbers from 0. So this is 0, 1, 2, all the way to the last number, which is what we have here, all the way to n. Okay, so n is whatever number that is there. Okay, so to put it in perspective, let's look at an example. And we're just going to use a simple example, but the activities that I'm going to give you will be quite involving. So let's see what we can do. So basically, let's say we're asked to expand, let's say 3x plus y squared to the power, I'll use 4. Let's start with 4. So you're asked to expand that. So generally, this is more like your a, and that is your b, or this is your x, and that is your y. So basically, what you're going to do using the binomial theorem, you're going to say this is basically equal to the sum from I equal to 0. So I always starts from 0, and our n is 4. So to 4, then we're going to say n choose I. So we're going to say n, our n is 4, choose I. So always write the formula before you start expanding. So always write the formula, the binomial formula, before you start expanding. So then we have x to the power I. Our x is the first term here, so we're going to write 3x raised to the power I. So we're just writing it generally. Then times y, which is the second term, y. In this case, the second term is y squared. So we have y squared raised to the power n, which is 4. We're using this. So n is 4 minus I. Okay. So that is what we have. And basically, I will run from 0 to 1, 2, 3, and the last one will be 4. Okay. So what we're going to have is 3x plus y squared to the power 4 equal to the sum. So now we'll start replacing in. When I is 0, what we're going to have is 4 choose 0. Then we're going to have 3x, the power I is 0. So this will be 0 times y squared raised to the power 4 minus 0 when I is 0. Okay, that is when I is 0. Plus, now we go to when I is 1. So again, we replace in the formula, so that would be 4 choose 1, and we have 3x to the power 1. Then we have y squared to the power 4 minus 1, which is our I. Then we say plus 4 choose 2. So we are from 0, 1, 2. 4 choose 2. We're going to have 3x to the power 2 because that is our I now. Then y squared raised to the power 4 minus 2 plus 4 choose 3. We're going to have 3x to the power 3. Then y squared to the power 4 minus 3. Then finally we are at 4 choose 4 when I is 4. Then we're going to have 3x to the power 4. Then y squared to the power 4 minus 4. Okay, so now Madam Joanne, this is where the reduction of powers and increasing of powers coming from. You see, you have on this first part we have 0, 1, 2, 3, and 4. Then on the other part we see that we're going to have 4 minus 0, that is 4, 4 minus 1, that is 3, 4 minus 2, that is 2, then 4 minus 4 minus 3, that is 1, then 4 minus 4, that is 0. So this is where we are going to have the reducing of powers and the increasing of powers. So that is, I hope that answers your question. So now from here, we just start simplifying. So we say 3x plus y to the power 2 to the power 4 will be equals to, what is 4 choose 0? When you punch that on your calculator, that will give you 1. So 1 times this raised to the power 0. So any number raised to the power 0, that is basically 1. So this raised to the power 0, that will be 1. So 1 times 1, that is just 1. Then what we're going to have is y to the power 2. Then 4 minus 0, that is 4. Plus 4 choose 1, that is 4. Times 3x. Then we have y to the power 2, then 4 minus 1, that would be 3. And we continue, 4 choose 2, so that will give you 6. 4 choose 2, that will be 6. Then where we were here, 4 choose 2, that is 6. Then we have 3x to the power 2, which is this. Then y squared to the power 2 as well. Okay, you can see that. Let me just bring this part. So now that is that. Then we are here on 4 choose 3. So 4 choose 3, that is basically 4. Then 3, we have 3x to the power 3 times y to the power 2. Then 4 minus 3, that is basically 1. So this is to the power 1. Then plus 4 choose 4, that would be 1. Then times 3. So basically we can't write 1, we can just leave it like that. So we can say, because we are multiplying here, so this is 4 choose 4, that is 1. Then 3 to the power 4, so that we're going to have 3x to the power 4. So since we are multiplying, there is no need to write 1. 1 times anything, it will just be that thing. Then here y squared, so y squared to the power 0, because 4 minus 4 is 0. So any number to the power 0, that will give us 1. So this whole thing is 1, so there is no need to multiply it to this, because it's just 1. So 1 times everything, that would be that thing that we have there. So now from here you further simplify. So we multiply the powers. So we're going to have, I shouldn't put the equals here, there should be a plus here. So here we're going to have y to the power, the powers are multiplying, 2 times that, so that will be to the power 8, plus we multiply everything here. So 4 times 3, So we take note that there is no power here, so we can distribute the 4. So 4 times 3, that will be 12x, then y to the power 6. Here we cannot distribute the 6 because this has a power, so we need to simplify this. So this is just the same thing as 3 raised to the power 2 and x raised to the power 2. So this will simply be 6 times 9. So 6 times 9, which gives you 54. So this will be plus 54. So this will give you 54. Then now x to the power 2. X to the power 2. Then here we have y to the power 4. Because 2 times 2 will give us 4. So you need to take note here. See, this 2 is distributing. So you distribute it inside first. Then you distribute what is outside like that. Okay, or basically it's just with one variable, so you just distribute what is outside like that. Then here we do the same, so this again will be 3. The 3 distributes inside, so this is x to the power 3 and 3 to the power 3. So 3 to the power 3, that is 27. 27 times 4, that will give us plus 108. 108. Then here we have x to the power 3. Then here times y times that, so that is just y to the power 2, then plus finally 3x to the power 4. Okay, so that is how you expand using the binomial theorem. Okay, so it makes things easier. So you can try, you go through this, try to expand without looking at the example, then you run through, then I'll give you some questions. So basically, suppose, let's say we had, let's use a simple one, a plus b raised to the power 2. If we were to use the binomial theorem, this would be equals to the sum from I equals to 0 to n. Our n is 2. Then we say n choose I, so that is 2 choose I. Then a to the power I, then b to the power n minus I. So our n in this case, that is 2 minus I. Okay, so now I runs from 0 to n. So I runs from 0, 1, and 2. So because our n is 2, so it runs from there. Then we start putting in the values. So when I is 0, that will be 2 choose 0. Then a to the power 0. Then times b to the power 2 minus 0, which is just 2, plus when I is 1, so that will be 2 choose 1 times a to the power 1 times b to the power 2 minus 1 plus 2 choose 2. This will be our last one. B a to the power 2, b raised to the power 2 minus 2. So what is 2 choose 0? That is 1. So 1 times a to the power 0, that is basically 1. So it will just be b raised to the power 2, because 2 minus 0, that will be 2. So b raised to the power 2 times 1 is just simply 1, plus 2 choose 1. When you punch that on your calculator, that will give you a 2. Then a raised to the power 1, b raised to the power 1, because 2 minus 1, that is 1, plus 2 choose 2, that is 1. So 1 times a raised to the power 2, which is just a raised to the power 2. Then 1 times what we have here. So b to the power 2 minus 2, that would be 0. And b raised to the power 0, that is simply 1. So we just have 1 here, so which is just a squared. So now simply putting it, a plus b to the power 2 will be equals to b squared plus 2ab plus a squared. So you can try this, you're going to get the same answer. So now let me put up some examples for you to try out, then we see how you fare from there. So you're going to do these questions. We have 3xy plus b raised to the power 4, a plus b raised to the power 5, 3a squared plus 2ab raised to the power 6. So you're going to expand this and simplify. Then we'll see how you do it from there. I think let me put one more question. Say I'll just put a simple one. So this is 7ab plus a to the power 3 raised to the power 3. Okay, so try out these using the binomial theorem, then we see how we get from there. So basically the binomial theorem just helps us expand things easily, and it makes our work much easier. So have a good time working these out.